Coming to the next topic is sum of two random variable. Till now we have seen only for a single random variable as value as x. Okay, now coming to the next one, it is two random variable. Let x and y be the two independent random variable and the sum be w. So we can write as w is equal to x plus y. Now the probability distribution function is given as f of w, this is capital W, into f of within the brackets w is equal to probability of w less than or equal to w, which is equal to probability of x plus y less than w. Now in the previous thing, when we were studying about single random variable, how we were writing? For the single random variable we were writing as f of x is equal to probability of capital X less than small x, right? Now over here, since we are using two variables, we can just assign the two variable x plus y as some other variable as w, or we can keep it as it is as x plus y. This is in the discrete form. Okay, now for the same thing we can write in the continuous form as integration over the limits minus infinity to plus infinity, integration minus infinity to plus infinity. Why is there two integrations which is coming? Because we are taking two random variable x and y. One limit is for x, another limit is for the y, into f of xy into x comma y dx and dy. Now we have two variables, hence we have two values as dx and dy. In the previous one, if we were just considering single variable, we would have written as integration f of x dx. If we talk about single variable as x, suppose if we take a single variable as y, I can write as integration over the limits minus infinity to plus infinity f of y into dy. Okay, since it is two variable, I am writing as dx and dy. Now within this we shall be studying the next thing is joint distribution function. Now when we are saying joint distribution function, in the previous one we studied about distribution function, probability distribution function. That means the probability distribution function was for the single variable f of x, right, or single variable f of y. But over here we are studying about two things. One is one variable x, another is another variable y. That means we are studying about two variables. So let f of x and f of y represent the probability distribution function, or it is also called as cumulative distribution function of the two random variable x and y respectively. Now I can write this in separate form. This form which is being written is in discrete. F of x is equal to probability of capital X less than or equal to x. This is for the single variable x. Similarly, for the another variable y, I can write as f of y is equal to probability of y less than or equal to y. I have written two variables separately. Now the probability of joint event comes into picture when we have both x comma y. So this can be written as the probability or the joint probability of an event is given as mod of x less than x comma y less than y, is defined as the joint probability distribution function, and it is denoted in general as f of xy, x of comma y is equal to probability of capital X less than or equal to x comma y less than or equal to y. When we are writing over here, this is only for the single variable. I can write single variable separately, another single variable separately, but since it is joint, it should be always mentioned with both x and y into the picture. We have joint distribution functions, few of the important properties associated with it for the two random variable x and y. The first property says that if f of x comma y lies between minus infinity to plus infinity, it is equal to 0, and distributive function f x comma y ranging from minus infinity to y is equal to 0. When you are saying minus infinity to y, that means this is the minus infinity is the lower limit, upper limit is y, and f of x comma y is equal to x comma minus infinity. So the lower limit will become x and the upper limit will become y. If you see in total, the limit starts from minus infinity and it is ending at minus infinity, okay, which is equal to 0. Next property, it says that always the value of f of x comma y lies between infinity to infinity is equal to 1. And third property says that the function f of x comma y within the limits minus infinity to plus infinity lies between 0 and 1. 0 and 1, or else you can write this equation as the f of x comma y within the bracket x comma y lies between 0 and 1. Always your probability function lies between 0 and 1. Now this function, that is probability distribution function, is a non-decreasing function and non-decreasing function of x and y. The next property says that f of x comma y within the bracket x comma minus infinity is equal to f of x, and f of x comma y minus infinity to y is equal to f of y. What does this indicate? This indicates it is a marginal function of x for a distribution function. This indicates it is a marginal function of y for the discrete function. When we are saying discrete, this f will always be in the capital form, capital letters. This f will be in capital letters. For the discrete function, we are just writing it separately as marginal probability mass function. If x and y are discrete random variable with the joint probability mass function f of x comma y, then the marginal probability mass function of x and y can also be written as f of x is equal to summation f of x of y. Over here you are able to see, when you are talking about the marginal function of x, you are considering the summation with that of y. Now when we are considering f of y is equal to summation x f of x comma y, when we are taking y, we need to consider the summation for the case of x. We shall be seeing the problems related to it.